Very good afternoon, everyone. I welcome you all to the third day, second session for multi-carrier modulation techniques for 6G wireless communications. Now I would like to introduce our today's speaker, Dr. Prabhu Chandar. He is a Director of Basic Wireless Laboratories Private Limited, Tamil Nadu. Dr. Prabhu Chandar received his bachelor's degree from AVC College of Engineering in ECE and master's from College of Engineering, Gandhi. He worked as a senior research fellow, Vodafone SR, IIT Center of Excellence in Telecommunication from IIT Kharagpur and 15 and has received doctoral award from IIT Kharagpur in the area of telecommunication for the next 2 years. And Dr. Prabhu Chandar has a wide industry experience also. He has worked as a director from 2018 in Chandar Research Labs, and currently he is working in as a director in Basic Wireless Laboratories Private Limited, Tamil Nadu. Thank you, sir, for accepting our invitation. And now I will hand over the session to our speaker, today's speaker. Thank you.
Thank you, ma'am, for the kind introduction. My voice is audible, right? Hello?
Audible, sir.
Audible, okay. So, good afternoon, everyone. So, in this session, I will be discussing about experimental 5G. It's like how to, perform real life experiments with the testbed and what are the steps moving towards 6G and all. So I will discuss about how the 5G system evolved from 2G, and then I will discuss about 5G use case and applications. Then discuss about what are the various test beds available in the market, and we will also show some outputs from the test bed. What are the experiments we can conduct from that? I will explain. Then I will also discuss about Open RAN. This is a summary of evolution of industry from 1.0 to 5.0. So we know that the industrial revolution started from mechanization from 17th century. Then the electrification happened. Then industry 3.0 mainly focused on computers, automated machineries, all those things. Then industry 4.0 started from 2000s, then mainly focusing on digital mode of transmission of information between the machineries, human interaction, all those things happened. Then currently we are in the era of industry 5.0. That means human machinery interaction, right? So moreover, all these things are going to happen in a wireless manner. So wireless plus digital. So combination is going to give industry 5.0 from in this decade and also next decades. So how and similarly, so this is how the industry evolved from 1.0 to 5.0. Then similarly, we also had a different evolution for wireless communication, particularly cellular communication from 1G to 5G. So we know that 1G to 4G, they are mainly focused on voice, SMS, and data communication. Then 5G come into picture with a few more capabilities, enabling the industry 4.0. So with ultra low latency, AR, VR interactions, and industry automation kind of thing. So for 6G will be towards more artificial intelligence supported communication system, and also holographic. So without physical presence of the human on other essentials, so we can make the industry work. So it include digital TV and all those things come into picture here. So when we talk about 5G, other than the voice and data communication, we are also going to have vehicle to vehicle communication, all those things. For those things, we need ultra low latency. So drones, vehicle to. So this is summary of evolution of solar system from 1980 to 2020. For every 10 years, we are having these each generation of systems. So initially 1G and 2G are focused on only voice services. Then 3G, little bit of data rate for data communication, browsing internet, all those things happen. In 4G, primarily based on IP based. That means whenever you are connecting your smartphone to the network, your phone will be getting the IP address. That means now it becomes cellular phone also part of the network since it has IP address. So you will be able to do voice communication, email, the web browsing, audio video streaming, all those things. Till 4G, it was meant for human communication. That means you are having smartphone and using it for your personal use and all those things. When it comes to 5G, not only human communication, we will be involved in the uh, Internet of Things. That means Internet of everything, basically. Be it your vehicles, cars, trucks, and your home appliances, in industrial point of view, industrial machineries, all those things can be connected to the 5G network to have these industry 5.0 evolution. To meet the demands of industry 5.0, our 5G and 6G is going to be going to play a major role. So basically, the major difference between 4G and 5G is that 4G is meant for human communication, right? And 5G is other than human communication, it supports a lot of devices, be it agricultural domain, transportation, all domains basically, lot of everything. So whenever you do work in our wireless communication domain, we focus on physical only, but technically we have to focus on core network also. So this is a summary of your cellular system architecture. So the bottom one is access network. Access network means your cell phone and the base station. They commonly make the access network. Core network is the network that controls the base stations. So that is here you can see the 2G, 3G, 4G, and 5G systems. In 2G, you have studied base stations called as base station transfer system. The base station switching center is controlling the base stations. Then on the core network, there are modules for controlling the registration, all those things, right? Like HLR is basically home location register that will have the database of your SIM card information. And there is a visiting location register. When you are moving from one network to another network, that means one state to another state, all those things will be recorded in the visiting location register. And there are some gateways to connect it to the network. It's for basically 2.5G, we have it to GPRS also to connect to the internet. No? That is gateways. Serving gateway and data gateway. So it is 2G point of it is simple. We have a home location register, visiting location register, and some gateways to connect to the internet. That's it. When it comes to 3G, the base station is renamed as node base station, NB, node base station, and there is a radio network controller that controls the cell towers. Then it is an extension of the 2G only, 2.5G, and few more capabilities. So either the node base station directly can connect to the gateway or via radio network controller. So and then we had 4G. In 4G, the node base station is called as evolved node base station, ENB in short. Then the core network, if you see, there are some components: MME, HSS, SDW, PGW, and PCRO. Here, MME is the entity that takes care of mobility. That is mobility management entity. So when you are moving from one state to another cell, no, you have to do a handover, all those things, right? That will be handled by MME. And we are moving one place to another place and one state to another state, one country to another country, no? That movement will be controlled by mobility management entity. And here HS is the home subscriber station that is responsible for authentication, all those things. Whenever you are having a phone, turning on the phone, first your information has to be authenticated by the network. So that means your simple information will be saved in the core network in some module, right? That is called home subscriber registration. That is responsible for registering your phone, first time registering your phone into the network. Then there is a HW and PGW. They are gateways, serving gateway and PDM gateways. Um, they are responsible for assigning IP address to your phone, then arranging the call flow in terms of whatever may it be voice call, WhatsApp call, or YouTube video streaming, or video uploading, or game playing, all those things. So that is the internet, right? That is responsible. The SDW and PGW are responsible for interacting with the internet. So the entire core network of 4G is called Evolved Packet Core (EPC). Evolved Packet Core. Okay, this is for 4G. So what happened with 4G in 3G? Let's say 2G, 3G, and 4G. So each vendor is making the components of the core network. We need to access network and the core network, both base station and the core network side. Companies like Nokia, Siemens, Ericsson, Huawei, they were making these entire core network architecture and selling to the operators, right? Even the base station and the core network. Whenever they want to move from one generation to next generation, be it 3G to 4G or 4G to 5G, they have to uh, buy the new setup, right? When we are moving from 4G to 5G, we have to replace the hardware and all those things. No? That costs a lot of money for the operators. If we, for example, in India, we have 20 lakh base stations, including 2G, 4G, and 5G base stations, more than 20 lakh base stations. So, and also for a lot of core networks for multiple places. If we want to change them, we have to, the operator has to spend several lakhs of crores, right? So a lot of revenue loss also related to that. So what happening now in 5G? In 5G, the base station is called a GNB, next generation base station in short. Short form, it is GNB. Then the core network components are modified as a services instead of fixed hardware platforms. They are running in FPGA and high-end software hardware platforms and server machines, and we can implement it as a software packages. Right? For example, AMF is access mobility function, access and mobility function that is responsible for mobility, all those things. So it is doing the same job of MME in the 4G, and AU is separate authentication function, session authentication user function for handling the user information. And UDM is the unified data management for user database. All SIM card information, security things will be saved in the UDM. PCF is the policy charge function, and UPF is the user plane function that is responsible for assigning IP address to your smartphone. And SMF is the session management function. So you will handle the sessions like video call, video streaming, or web browsing, or voice call. According to the request, it will assign some pipeline so that the data is handled properly. So, in compared to 2G, 3G, 4G, in 5G, the core network calls is implemented as a services. That means you do not have a physical hardware component in particular place. You can keep that core network in cloud also. For example, you can use Amazon Cloud or Google Cloud. The operators can pay a yearly rental or monthly rental to the cloud platform. They can use it. They do not have the physical hardware in their location, so they can keep it in the cloud and they can run it. That is advantage. So when they are moving from 5G to 6G, what they can do is just they need to upgrade the software, right? They need not to buy a new hardware or something like that. So just need upgradation. So a lot of money saving for the operators. That is the thing happened with respect to 4G. So in the physical point of view, there are some changes, but major changes in the core network. We are replacing the core network components as software packages, so that when we move to next generations, we can just upgrade it. That is the biggest advantage in 5G. So whenever we are doing research in these days, we have to focus on the core network also, because the job market is more on the core network side. Because whenever you get any applications, all those things, lot of work has to be on the core network side in compared to base station side. So, so now, how is the 5G and 6G going to empower the 5G Industry 5.0? Here, we are going to be connected wirelessly with the machineries and the equipment or the vehicles, all those things. Then we have to be there physically. So from remote place, we will be able to enjoy the services. For example, already we know self-driving cars already there. So now self-driving trucks, even agriculture domain, we have tractors are manless now. Driverless tractors are there. So remote surgery. In these cases, you have to physically be present. We can use robots and machineries to automate the process. That is the biggest advantage. That this is possible because of 5G and 6G services. And there are multiple access edge computing. So instead of processing something in the cloud, we can do things locally. I will explain that the examples. So and also several lakhs of rows of um, devices can be connected. So all can be automated. We can have very high-level intelligent networking system. So in the job market point of view, we have a lot of domains. In telecom operators, Geo, BSNL, for maintaining network and all, they need manpower. And 5G, 6G R&D point of view, lot you know already Samsung, Qualcomm, Nokia, Huawei, Ericsson, they are creating a lot of manpower for R&D purposes. And the chip semiconductor already you know Intel, Samsung already there. Now, government of India also focusing on semiconductor industry, right? Already they will subsidy to certain companies to start um, factories, all those things. And in satellite space defense lab also a lot of opportunities when you equip with 5G, 6G stuffs. And also all startups are going towards artificial intelligence, wireless, robotic, mix of all those things. So a lot of job opportunities in this telecommunication. But here my point is not only on the physical layer point of base station side, we have to think beyond the physical layer on the base station side. We have to work towards core network in the overall application building, all those things. So if you think of our telecom market in India, more than 120 crore populations. That means all are having mobile phones, and it's a 3 lakh crore telecom industry. It's a very big one after a high industry in India. Then already you know Jio and Airtel deployed 5G throughout India. So as of now, we don't have much contribution towards technology, be it a 4G or 5G. The Indian contribution is minimal. So India is aiming to be a leader in 6G the next 5-6 years. Going towards 2030, we will be having 6G. So already you know Bharat 6G and such projects, such initiatives have been taken by Government of India. They are giving a lot of funding to startups and academic institutes. They are supporting this stuff. So one good example is that you know all are started using this UPI based transactions, right? So whenever UPI things are involved, the security is a primary concern. So Government of India already is focusing on cyber physical systems. Whenever the academics are applying for projects, such things, they are coming under cyber physical systems. So to secure the payment, all those things, it involves the communication, cryptography, cloud AI, all those things. So the second point of view, so as I mentioned, there is going to be not only 120 mobile phones, a lot of billions of IoT modules are going to come in, going to be connected to the 5G 6G setups. So the security becomes a major concern, and the number of devices are increasing. Handling the network is not that easy task. So we have to implement AI algorithms to run the network automatically without any human intervention. Including self-driving cars, drones, and smart factories, they all be equipped with AI and wireless. So in summary, AI, wireless, and digital concepts, security, all those things are going to enable the all industries from textile, transportation, agricultural, all areas they are going to be um, 6G and 5G, 6G supported. When it comes to digital those things, already we know keywords like Digital India, Make in India, Semicon India. Um, for enabling telecommunication, semiconductor industry, I think 2 weeks back, Government of India has given subsidy of 40,000 crores to Tata to start telecom semiconductor factories. And BSNL, Government of India has given more than 20,000 crores to deploy for 4G base station to BSNL and other startups, so that entire 4G setup is developed and deployed by Indian organizations. So a lot of things are happening in the 6 years. We can see a lot of booms in this oral domain. So when it comes to agriculture, we are having a smart irrigation, crop monitoring, autonomous tractors. So this will save a lot of hurdles for the farmers, and the government of India also we can save a lot of money because government of India only giving a lot of subsidy for fertilizers, all those things, right? This can be reduced if you intelligently monitor the soil and crops. So the last comment also reduced. So already industrial automation is happening. Smart factories, robotics, and low latency applications are already being built to make the factory smart. Transportation point of view, already connected cars, uh, smart traffic management systems, autonomous vehicle already in the pipeline. So same thing with healthcare and smart city management. So whenever you're talking about uh, 2G, 3G, 4G, 5G, there are two major players there involved. One is ITU, International Telecommunication Union, and another is 3GPP, Third Generation Partnership Project. ITU is basically is an agency of United Nations. Almost all countries in the world are part of ITU. ITU is responsible for turning the name 4G or 5G. So basically, ITU will put up the requirements for 4G and 5G. 3G is the private organization. It's a consortium of academic universities across the world and cell phone operators and cell phone manufacturers all are part of 3GP. So ITU is the organization that will put up the requirements for 4G and 5G. 3G is the organization that develop the technology for 4G and 5G. For example, 2G, 3G, 4G, 5G. That means GSM is another name for technically global system for communication. That is 2G system developed by 3GP, it's still maintained. And UMTS, LTE for the 4G, 5G and 5G radio for 5G, all are maintained and developed by 3GP. When you think of 3GP, basically it's collaboration between academic across the globe and companies like Samsung, Qualcomm, maintaining the standards. For example, there are some 7 regional organizations from India. TSTSI, Telecommunication Standards and Development Society India, that is responsible for participate with the standards. So if we want to contribute to the standard, we have to approach through TSTSI to 3GP to make contribution to the standard. So, and ETSI is the entity in European countries. So, as I said, ITU is responsible for ITU. In the x-axis a year, in the y-axis we are having different generation networks. So, for example, in 3G, there are three phases in development technology, be it 3G, 4G, 5G. There are three stages. One is vision statement for the services. 4G or 5G, there is vision statement from ITU. That is a requirement by the ITU. The development stage, then deployment stage. So the initial vision statement requirements for building will be done by ITU. That will happen for 2 to 3 years. For example, 4G will happen from 5G 2012 to 15, 3 years they made. Then the 3GP started the development from 2003 to 12. So in the 9 years they are able to develop the 4G technology standard. And for 5G, it was for 15 to 20. Within 5 years they are able to develop it. So the 4G development happened in 2012 and 5G deployment happened in 2020. So when compared to now 4G, 5G is much faster. So the development of 6G will happen much faster. Within 3 years, they are able to develop it. Already they put up the vision statement for 6G, and the deployment will happen in 2030. So exactly after 10 years, we will be having 6G. So whenever basically 3G point of view, it's their releases. For example, release 13 basically it's here. Release 13 is 5G. So they once they release 5G, they won't stop. They keep working on the updates. So they will every 1 or 2 years they rename the releases. Release 14, 15, 16 like that. So currently they are running release 18. So whenever the release becomes release 21, 22 like that, it becomes 6G. So whenever release becomes 30 something like that, it becomes 7G. So technically 3G point of view, the releases for ITU defines for every 10 years there is a 5G, 4G, 5G like so IMT advanced. In 5G it is IMT 2020. Okay. For 6G it will be IMT 2030. So this is the requirement from ITU. Whenever you want to connect as a 4G services or 5G, these are this is a proposal for 5G. So this is the data that each patient has to give 20 Gbps for downloading and uploading 10 Gbps. And per user the report will be 100 Gbps for downloading and uploading. Latency is 4 milliseconds for a particular there is a whole broadband, 1 millisecond for ultra variable low latency. And here EMBB is basically video and data communication. URLC, ultra reliable low latency is for connected vehicles, drones, whenever connected, latency is very important. So connection density is basically 10 lakh devices per kilometer square. In 4G it was 1000 devices per kilometer square. The connection density is home appliances, sensors, all the vehicles, all those going to connected now. So number of devices will be very huge number in 5G. In 5G we have 100 megahertz of bandwidth. So it approved by as a 5G services in ITU. Technology we can see release 12 small cells and carrier aggregation, device communication, and mobile vehicles. So you can see NS support for UAV. That means integrating the drones and enhancement of ETX. For this 7 or so, will be CT1, CT2, CT3, CT4, and such that RAM access network, physical layer, MAC, RLC, all those things. So, 3VP partners are working in splitting the work items and for 24, right? Already is in 2024 they put up the requirements. I started working on the requirements, and by 2027 end they will be. I mean, start of 2027 they will be. IDU will define the requirements for 6G. Then 2027 to 2030 they will make the standard. The 3G will work on the standard development. Then 2030 onwards we will be having deployment 6G base stations, and we will be having 6G smartphones, all those things. So compared to 5G, the 6G development will happen only 3 years. Supporting startups and academic labs to contribute to standardization. Because already they have given fund for establishing 5G labs in 100 use case lab in 100 institutions in India. Already they have given like this 6G projects. A lot of things happening. So technically, the difference between 4G and 5G is 4G gave 1 Gbps and 5G is giving 10 Gbps. Latency is 20 to 30 milliseconds, and in latency is less than 10 milliseconds 5G. The carrier frequency was supposed to be 2.5 GHz up to 2.5 only in 4G. In 5G we can now more than 6 GHz. Like basically 4G work sub 6 GHz frequency range. 5G is capable of working on sub 6 and 6 GHz range up to 30 GHz. So the main target of 5G is to give 98% almost 100% availability everywhere. So this is enabled by higher bandwidth support. Basically 4G support here only 20 MHz bandwidth, 5G system. For error correction we have LDPC, Polar course, 0.5, Polar course, 0.5G. We have advanced to enable ultra reliable low latency services. So in 4G bandwidth 1.4, 3, 5, 10, 14 like that. In 5G we have this configuration 5, 10 up to 100 MHz bandwidth. These are the frequency bands used by the 5G these are the frequency bands used by the 5G setups. These are the bands also used. Whenever the 5G services are not there in particular band, this will be used by 5G. So massive is one concept you already know. When you deploy large number of antennas at the increase the throughput and as I said, 5G is able to support sub 6 plus millimeter band. So currently deployments are there and only sub 6 because practically it is will depend on you. Sub 6 GHz is more suitable for operators because it gives wider coverage and all. That's why we are using sub 6 GHz. Millimeter terahertz also possible to 6G and all for indoor applications. But practical applicability you have to see it whenever it is deployed. So edge computing is another approach to process the data. Instead of sending the cloud, process locally. That means we can do processing within the cell tower itself. If you avail more capability to the base station itself, it can perform a lot of operations. So it gives to reduce leverage. For example, when you're connecting the vehicles, autonomous vehicles and drones, when there is a feedback mechanism video and all those things, we need a very short latency, a small latency. In those applications, is very useful. So basically 4G was mentioned for the public telephone communication, smaller communication. That means all the decisions in the third